Hi everyone, glad to be here. A few words on TLF. We're a software company, and today we're going to focus on the network control system, NCS. What is NCS? NCS is a product that lets you abstract the network services and the network devices and provide one unified interface to that. And that includes open-flow switches, include virtual appliances and legacy devices. So connecting back to the previous speaker, for example, in the Havana release of OpenStack, there is an NCS. We shouldn't say plugins because plugins are a little bit old-fashioned. There can only be one, so there is an ML2 driver in the Havana release so that OpenStack can fire off a network change request to NCS, and NCS will provision that in a multi-vendor network. So we're sort of the engine that makes configuration happen in the network. So what I will talk about, why are we talking about service programmability? And to achieve that, what are the requirements? Look at some architectures, and at the end I will show two deployed use cases that actually are up and running. So SDN and NFV are strange buzzwords, but you can utilize that to reach goals, and I will show you two use cases that we have implemented for service providers. Why NFV and SDN? Sort of going back to why do we do this, and I think it's quite interesting. I met Don Clark here in the break, and we were part of an initial NFV project together with British Telecom and HP, and at those times we talked quite a lot of reducing costs. Rather than having 10 boxes for 10 applications, we talked about one box with 10 applications, so it was purely a cost-saving thing as priority number one. I would say that that has actually changed to getting more business out of it. So this is actually from a research from, oops, I shouldn't have pressed that one. From Infonetics research. Why are service provider adopting SDN and NFV? And the two interesting things here. Service velocity, quicker time to new revenue. And that I would say has what is that really? Well, if you look at current service activation, whenever you have brilliant marketing guys that invent a new service that you would like in your portfolio, typically it takes 6 months until you have your network and your OSS system to support that, because you need to bring 20 integrators in to rebuild your OSS system to have that new service in your service catalog implemented. So this is making it easier to adopt the service portfolio. Should take days, not months. Shouldn't require 20 integrators. We will look at a project we do together with Deutsche Telekom at the end that actually address that specifically. And an old, boring problem. Do we think that VPN provisioning is solved? 2 years ago, we went quite a lot to conferences on network automation. If we would have a conference today with the title Device Configuration and Network Automation, I think we would have 2 delegates. Boring stuff. SDN is much more fun. But if I meet service providers today, provisioning MPLS VPNs is still manual, it's still errors. So we're actually solving that same problem with SDN and NFV problems. We need automatic service activation, we need automatic provisioning, and that is unsolved. I would say the 2 main concerns I see at providers is VPNs, access control lists, firewall rules, still not solved. So that is the goal here. So what about service programmability? We work together with Deutsche Telekom. You might have read about an interesting project called TerraStream. If you have not, if your tech is in the room, read up a bit on TerraStream. It's a very interesting project where TerraStream, what Deutsche Telekom has realized as being a service provider is that in 5 years, we will maybe not be as profitable as we are today because we can't decrease the cost of operating the network. And the services we are selling is getting cheaper and cheaper. But we still need engineers clicking element management system to provision the services. That is not future-proof. We need no-hands service provisioning. And I think also it's interesting looking a little bit on OpenFlow in contrast to what US service providers are interested in. As Axel points out, maybe if you're running a network, maybe you're not that interested in writing OpenFlow C programs. Does that actually bring you money? No. What you're interested in is bringing your VPNs to your customers. So it's extremely important to focus on the services we are selling to our customers. Those must be automatically provisioned. That's what gives you money back as a service provider. And OpenFlow is a piece in the puzzle to reach that, but it's not the goal, I would say. Things are not cheaper if you rip out all your Ciscos and Junipers and just replace them with OpenFlow switches. There is a few lines of software that needs to be written if you do that. Service provisioning today. Let's say you need a VPN. This is how it looks today. Because you talk to your integrator, and the integrator comes back 6 months later with maybe some Perl and Python scripts, or you go to your Ponytails in the basement that does the manual configuration. This is where we are today on VPN and ACL provisioning. So bring me the salt. That was sort of the background. How can we achieve that? How could we actually reach a state where we have our access control lists, where we have our VPNs, where we have our broadband services, where we have the evolved packet core services, that we can touch upon them and they actually happen in the network, that don't assume humans. How can we reach that? And this is my private Stefan Wallin list. This is not from Open Network Foundation. This is not from SDN Central. This is my private requirement list. If you are a service provider and you need to reach a state where you can say, bring me the salt and you get it, these are the fundamental architecture principles I think you should strive for in your, if you call it NMS system or your activation system or OSS system. First of all, tying back to SDN concepts here, you need centralized abstractions of the network services. And I'm talking about the end-to-end services that you provide to your customer. Again, taking the boring example of VPNs, you need to represent your VPNs somewhere centralized, logically centralized, well-defined. So am I talking about a CMDB database? Am I talking about an inventory system? No. What's the problem with those kind of systems? They are offline. Going to requirement number 2. If I manipulate the service, it should be immediately, consistently reflected in the network. That's a big difference with today's offline systems. I have a central representation of the network service. I manipulate it. It actually immediately reflected over the OpenFlow switches, over the virtual network functions, and over the legacy devices. So that bullet number 2, fundamental. Move away from offline databases. Go to an SDN approach where you have the services represented and changes reflected immediately. How can we reach that? Well, first of all, it must be transaction safe. If I manipulate a service abstraction, we must use transactions towards the network. We can't just go on with CLI scripting, because if you touch a VPN across your CPEs, across your PEs, and there's an error on one router, typically today you give it to an engineer who tomorrow maybe fixed the problem. Go away from that. You need transactions towards the network. You need consistency. If you manipulate the service abstraction, you need that to be consistently in the network. And you need consistency checks and syncs between these two. So connect your management system with transactions and consistency to the network. It must be model-driven. What do I mean with model-driven? Do I mean graphical diagrams? No. What I'm talking about here is that tomorrow your marketing people are inventing a new WUS-bar service that you need to sell. You should be able to specify that service in a formal data modeling language and load that to the engine. You shouldn't require 20 integrators. Formal, well-defined abstractions. Going back, what is an abstraction? An abstraction is not a Word document. It's not a PowerPoint file. It's not the Visio diagram. It's a formal data model that can be consumed by software. You must specify your services in formal languages. If not, you still need 20 integrators. If you specify them in formal data modeling language, you can have software automated. So that is background. Are there architectures that adhere to this? Yes. I won't go into detail here. I would do a little bit of a commercial. If you haven't listened to Scott Schenker's videos, do so. Scott Schenker, talking about training, the best training material about what is SDN. Listen to Scott Schenker on YouTube. He actually separates the network into, again, an abstract network view and a global network view. So this is the layer where you represent your services. And you can actually manipulate the services, and they can be transformed to the actual changes in the network. That is SDN, defined by Scott Schenker. Going back to my definitions here, the top layer here is where you have the representation of your services. They can be transformed to the devices in the network. NFV then, so I would say SDN and NFV are the two main themes here. This is the architectural diagram of NFV. NFV is the Network Function Virtualization Group by Etsy that we had a good introduction here on the first talk this morning. And this is pretty interesting. So what NFV is saying is that in the bottom, we have the virtualization layer, we have a virtual network, and we have a virtual infrastructure manager. What is this guy? Virtual infrastructure manager. I would say that's OpenStack. So the bottom box here, virtualized infrastructure manager, that is OpenStack. What is SDN? I would say SDN is here, so the laser pointer is sort of out of battery. It's the virtual network. In this architecture, I might be wrong, we can discuss this, but my mapping of this NFV architecture is OpenStack down there, SDN down here manages the virtual network. Then, according to NFV, the cool thing is that the functions, the virtual network functions, like a load balancer, like a firewall, that's not a box. That's a software piece you run on the virtualized infrastructure. And there's a complete management stack on the right here. And now things are getting a little bit interesting. I'm not, from an operational perspective, in this diagram, how do we actually decrease cost and reach quicker deployment of services? Because we have traditional OSS systems there, we have traditional equipment provider, EMS systems here. So this is, I would say, from a service provider perspective, I still have the same operational problem. I have EMS systems, I have OSS systems, and we had yet another interesting guy, the orchestrator. And the orchestrator for me today is everything we don't understand, everything we don't have a clue what it is, let's call it an orchestrator. But my question is, we have service activation, we have service fulfillment in OSS, and the orchestrator in the Etsy architecture is sort of doing the same thing, orchestrating the service. So I think what we will, my private guess again, we are part of this working group, so I think where we need to be much clearer is what's the role of the orchestrator really? What's the role of the OSS systems fulfillment stack? And do we actually still buy EMS systems from vendors? Don't we require open interfaces directly to the devices? That's my question. Our product then, what is it? How am I on timing? Few minutes, yeah. Our product is called TailF NCS. That's a network control system. Come on.
Did you press the button in the center?
No, I don't think so. Pressing back. I'm pressing next. Oh. Yeah. I can talk without the slide here. The network control system we have from TailF, southbound can speak OpenFlow, southbound can talk to virtual appliances, southbound can speak Cisco CLIs, F5 CLIs, so it can write configs to the network. Northbound of NCS is a service definition layer where you see your VPNs, you see your ACLs, and you can manipulate those. Oh, great. So, northbound of NCS is the SDN vision of a centralized API towards the network services. Whatever you do towards the services in NCS, be it service chains, VPNs, or whatever, is transaction safe written to a multi-vendor network, OpenFlow switches, traditional devices, virtual network functions. And it does that with transactions. So the VPN is provisioned or not provisioned. Can mix OpenFlow and traditional devices. Putting that into place in the SDN and NFV architecture, so we sort of fulfill the Scott Schenker SDN vision, and we live in the top of an NFV architecture where we do the orchestration and configuration of the virtual devices directly without requiring EMS systems. Two real-world use cases. Again, mentioned the Deutsche Telekom thing we're running. Deutsche Telekom needed extreme cost savings, and they did that by simplifying the OSS and simplifying the network. So they built a very interesting IP network. The first thing they said that the IP network must be extremely simple. We have too many people clicking things in our transmission systems. We can't have people clicking to provision a service. So they sort of killed the transmission network. It's a pure IPv6 network. It's optical interfaces to the routers. So the optical interface is directly to the routers, pure IPv6 in the network. And the network services are running in the data center. So here you have, if you need a IPv4 address, that's a software function. And they are using NCS as the SDN controller, as they call it. So we provision the whole IPv6 network and all the services in the data center. So that's a live network today in the Deutsche Telekom. Final use case here is an Asian operator, which is more puristic open flow thing. So this is a service provider in Asia that sells business enterprise services like VPNs. And for them, it's very important that customer A needs some firewall services, customer B does not. So for them, it's extremely important to have self-service customer portals where you can drag and drop functions into the service that you are actually buying. So what we have deployed there at this operator is, first of all, look at the list of vendors today. I mean, any SDN OpenFlow deployment today, there are existing devices. You can't just run the pure OpenFlow network to sell business services. You need some existing firewalls, you need some existing load balancer, etc. F5, A10, Riverbed, all of this stuff is in the network. And what NCS is doing here is that as one transaction over PK8 OpenFlow switches, we stitch the service chain. So we put together the service chain with OpenFlow. But within the chain, some customers need content filtering, some customers need one acceleration. You see customer A and customer B here. This is runtime, dragging and dropping pieces into a service chain. And these guys in the middle need to be configured as well. Some naive OpenFlow controllers think it's okay to put together the OpenFlow chain, and what about the firewall? Well, configure it manually, but then you're lost again. You need to configure the boxes in the chain as well, so that's what we do here. So that were two deployed use cases. Thank you. On time, or...